All right, let's dive into what is honestly one of the greatest detective stories of our time. I mean, the clues are scattered across trillions of miles, the suspects are entire worlds, and the mystery? Well, solving it could completely rewrite everything we think we know about our place in the cosmos. In this explainer, we're joining the epic cosmic hunt for new planets.
And it really all boils down to this one question. This is what drives the whole search for new worlds. We've found the basic, essential ingredients for life pretty much scattered all over the cosmos. So you gotta ask, if the raw materials are everywhere, where are all the kitchens? Where's all the cooking happening?
So, here's our first clue in this whole investigation. The universe is not some sterile, empty void. Not at all. It's actually more like a giant cosmic pantry, totally stocked with the fundamental raw materials you need to get life started. And I mean this literally. On these tiny, icy grains of dust just floating around in the cold between the stars, we have found complex organic molecules. These are the Lego bricks of biology. The fact that they're just out there, everywhere, that is the number one reason scientists are so confident that life could exist somewhere else. Okay, so if the ingredients are everywhere, how in the world do we find the planets where they might have actually landed and cooked up something interesting? Well, you start by casting the widest net you possibly can, using a really clever technique that lets us find planets by the thousands. It's basically a cosmic shadow play. You get a telescope, something like Kepler or TS, and you just have it stare at a patch of sky with thousands of stars. And it watches and it waits for a star's light to dim, just for a moment and just a tiny, tiny bit. Think about trying to spot a moth flying in front of a giant stadium light from miles away. That's the idea. That tiny dip tells us something just passed in front of the star. And from that, we can figure out how big it is. And let me tell you, this method has led to an absolute gold rush of discoveries. We went from wondering if there were even any other planets out there to suddenly getting these massive data dumps from the Kepler mission. I mean, they confirmed over 700 new worlds in a single day. It completely changed the game.
So where does that leave us today? Well, the count is now over 6,000 confirmed planets. 6,000. New worlds that we had no idea existed just a few decades ago. But you know what? Finding them is really only the first step of the investigation. Right, because just spotting a shadow, that's not enough. Now the real detective work begins. We have to figure out if our planetary suspect is a rocky world like Earth, or if it's just a giant ball of gas with no surface to speak of, no place for those Lego bricks of life to build anything.
So, a shadow tells us how big a planet is, its size. But to figure out what it's made of, we need to know how heavy it is. We need its weight. And we find that by looking for a tiny little wobble in its parent star. See, just as the star's gravity is pulling on the planet's gravity is pulling back on the star, ever so slightly, causing a little wobble that our instruments can actually detect. And this is where it all comes together. And it's so clever. As you can see right here, these two methods are a team. The transit method gives us the planet's size, the wobble method gives us its mass. And when you know the size, times, and the mass of something, you can calculate its density. And that is the key clue that tells us if we're looking at a fluffy gas giant or a dense, rocky world, the kind we could maybe, just maybe, stand on. So now we've got our prime suspect, a small, rocky world in just the right spot. This is the moment we bring in the big guns. We point our most powerful telescopes at this world to look for the final, most crucial piece of evidence, an atmosphere, a breath. We use incredible tools like the James Webb Space Telescope to do something called transmission spectroscopy. It sounds complicated, but the idea is brilliant. As the planet passes in front of its star, a little bit of starlight filters through that planet's air. And as it does, the different gases in the atmosphere absorb very specific colors of light, leaving behind a unique chemical barcode, a fingerprint in the light. We can literally read the air of a world light years away. And what are we looking for in that barcode? We're looking for biosignatures. We're searching for those exact same molecules we found on that cosmic dust way back at the beginning: water, methane, CO2. But now we're looking for them in a planet's atmosphere. And the holy grail, the absolute smoking gun, would be finding all of those plus oxygen. That would be a powerful, powerful hint that some kind of active biology is happening on that world. So, after all this searching,
all these techniques, what have we actually learned about our own place in the galaxy? Well, the results have been, to put it mildly, pretty surprising. It turns out our solar system might be the weird one. Yeah. Look at this chart. The most common types of planets we're finding out there, things called super-Earths, they don't even exist in our own cosmic neighborhood. This totally flips the script on what we thought was normal for how solar systems are built.
And check this out. While only a tiny fraction of the planets we've found so far are in what we call the habitable zone, don't let that small number fool you. Because when you scale that up, when you extrapolate that percentage across our entire galaxy, the potential is just staggering. We're talking about tens of billions of potentially habitable, Earth-sized worlds in the Milky Way alone. Billions.
Now, this cosmic hunt is so huge, and there is so much data constantly pouring in that the professional astronomers, they just can't do it alone. The search has become this amazing collaboration. And here's the best part. You can be on the discovery team.
Seriously, this is one of the coolest parts of this whole story. The big space telescopes give us the raw data, but there's just so much of it that computer algorithms can miss things. Through projects like Planet Hunters, you can actually log on and look at real NASA data yourself. Your eyes could be the first to spot that telltale dip in the starlight that signals a new world. Hundreds of regular people have already found new planets this way, right from their laptops. And that's what it all comes down to. All of this work, all the telescopes, the data, the citizen scientists, all of it is trying to answer this one massive question. Is life something that's bound to happen wherever the conditions are right, or are we an incredibly rare, precious accident? Each new world we find is another clue, another piece of the puzzle, bringing us just a little bit closer to understanding our true place in the universe.